This video is about comparing different exponential relationships and knowing when to use which formula. Okay, so the three types of exponential relationships we looked at is just a straight exponential growth problem, growth or decay problem, financial problems, and geometric sequences. Each of these has their own specific exponential equation that you're going to want to be aware of, particularly in the context of word problems. So our generic exponential function is y equals a times b to the x, but you want to be careful because sometimes it's easier to use it where it's broken down, where it's y equals a times 1 plus r, where r is your rate as a decimal, to the x. These are exactly the same. The b and the 1 plus r are the same. This version is just to help you guys when you're given a rate, but you need to change it into a growth factor, which is the b. Okay? So an example of that would be I'm going to erase this. A computer valued at $6,500 depreciates at a rate of 14.3% per year. We want to write an equation to model this. So we know it's exponential because it's decreasing by a percentage every year. So looking for our important values, its value is 6,500. It's depreciating at 14.3% per year. And we need to write our equation. So I could go straight into this, but again, this step is to help you guys break it down. So y equals your a, which is your starting value, so 6,500 times 1. Now, I have the plus there, but if it's depreciating, that means it's decreasing. So it's going to be minus 0.143 because you need to change it into a decimal to the x. So y equals 6,500 times 0.857 to the x. So that 0.857 just came from simplifying 1 minus 0.143. And this is my equation. So the financial version of these have to do with the investments. It's not just anytime there's money involved. It's just really when we're talking about investments. And the key word you are looking for to know if you're using this formula is when they start talking about things being compounded. If you see that word, then that means you are going to use the formula y equals a 1 plus r over n to the nt, where n is the number of times, and is really the only thing special here. N is the number of times your interest is compounded in a year. So for example, you may have a problem like this where you invest $1,000 in an account that pays 3% interest compounded monthly. So you see that word compounded and you know it's time. So we want to write an equation. So we're going to write an equation to model this. And we want to think about our important parts. So we have $1,000. That's my starting amount, so that's my A. We have 3%. So that's my rate, but we need to make sure that we change that into a decimal. Then we have 12, and that's my n. Remember, n is the number of times you compound. You're compounding monthly, There are 12 months in a year. So putting that into our equation, we will have y equals 1,000 times 1. It's increasing, so we will add. My rate as a decimal is 0.03. My n is a 12. And then to the 12t. So I don't know what that is. I don't know how long I'm going to let this investment sit, but that's what it is. So this is the unsimplified version. If we want to go ahead and simplify this, it's going to be 1,000 times 1.0025. So that came from taking the 0.03 divided by 12 and then adding it to the 1 raised to the 12t. So this is my equation. So my final equation is for the geometric sequence, and that's going to be a sub n a1 times r to the n minus 1. Now, this is a little bit different because in this one, an is just your nth term. A1 is your first term, so like all of them, this value here is always just your starting value. R is your common ratio, or your rate, and you don't need to add or subtract it in this because you're going to be getting it from this sequence, okay? So when you get it from the sequence, you don't need to add or subtract it from 1. And then your n is the n is your position number. In the sequence. Pay no mind to the ripping sounds in the background. That's just my bunny destroying a box. Just take a little bunny break here. Alright, so putting bunny aside, let's get back to our problem. So let's look at an example. So let's write an explicit formula for the sequence 200, 100, 50, 25. So the first thing you're going to want to do is identify, well, what's the pattern? And the pattern is I am taking half every time. So remember, when your sequence is getting smaller, you want to think, well, what am I dividing by? You're dividing by 2. Division by 2 is the same as multiplication by 1/2. So I now know that my A1 is 200 because it's always your starting value. And then my R is 1/2 because I have 1/2 as much each time. So then my equation for the explicit formula is just AN equals 200 times 1/2 to the n minus 1. So the only difference between this and sort of the generic form of our thing, so if we compare this to this, the only real difference is that instead of having ab to the x, we have it to the n minus 1, which is the same as having it to the x minus 1. Otherwise, it works exactly the same. All of these work exactly the same, right? The biggest difference that you should watch out for is really the word compounded, because then you know you're going to use this formula with the n's in it. You also know that with a geometric sequence, you don't really need to do the 1 plus, but with the other ones, you need to do the 1 plus. But for all of these, you can then use those equations that you wrote and make predictions about the future. So for example, let's say I wanted to know, okay, what is the value of the computer after 10 years? Well, we're just going to go ahead and use our formula. 65. Just going to move everything up a little bit. 6,500 times the 0.857 raised now to the 10th power. So please remember you need to raise to your exponent first, then multiply by the 6,500. So the computer will be worth $1,389.06 in 10 years. Okay, so similarly, let's say with your investment, you invested $1,000 at a rate of 3% compounded monthly. So let's say, how much is this worth after 10 years? Wallace. So 1,000 times 1.0025 times 12, or raised to the 12 times 10. So we're going to want to go 1,000. Simplify what you can simplify before you turn to your calculator. So, and then again, you need to raise your base. Whoops. You need to raise your base to the exponent first and then multiply second. You will find that your investment will be worth $1,349.35. And finally, in the geometric sequence problem, you might be asked, what is the value of the 10th term? Obviously, it won't always be 10 in your test, but I wanted to keep some things consistent across the board here. So that means we are looking for a sub 10. So we take our little formula and raise our 1/2 to the 10th power, and then multiply it by 200. And we learned that the 10th term is going to be $141.42.